Hello everyone, and welcome to this video where I'm going to be showing you how you can implement your own authentication and authorization in Next.js without using any paid third-party libraries like Clerk. We'll be using Iron Session to handle authentication and role-based access. And just to give you a quick preview of what this is going to look like, there's going to be a user dashboard that is only available to the user. If you're not logged in, it'll redirect you to this unauthorized page, or you can have it redirect to the sign-in page. There's also going to be an admin dashboard that is only accessible to the admin. And upon logging in, you'll be able to access this dashboard. Now, before we dive into the actual implementation of the code, I wanted to provide a high-level overview of how this authentication process is going to work. So typically, the user will input their information on the client in the form, and they'll send their email, password, username, or whatever to the server, and we'll go ahead and verify that information. And once on the server, we'll typically salt the password and hash it. That just adds an extra layer of protection, and we don't ever want to be storing their password as plain text on the database. So what we do is we add salt to it and hash it, and depending on if they're signing up or if they're signing in, the process will vary a little bit. But for example, if they're signing up, we'll go and store their email, username, or hash password in the database. And if they're looking to sign in, we'll go and find that user based off of some sort of identifier, whether it's their email or username, and compare the hash passwords. And if they match, we'll go ahead and create the user session. And from here, there's a couple different ways this can be done. So with Iron Session, what we're actually going to do is sign and encrypt a cookie and have it be stored on the client. You could do it another way where the session is stored in the database or with Redis, but with Iron Session, what we're going to do is have it be stored on their client. And anytime they want to access a portion of our website, they're going to send that cookie, and we'll verify that cookie, which will have their role or their ID and whatever useful information we need to give them access. All right, so with that out of the way, let's get into actually building the project. So right here, I already have a Next app initialized. So the first thing we actually want to do is implement Prisma. And to do that, you're going to need to type npm i-d Prisma. Awesome. So once that's installed, we're going to run npm install at Prisma client/client. Awesome. And after that, we'll do npx Prisma init. Once that's done, you'll see that in our source folder, there will be a Prisma file where we can put our schemas. Cool. And in our scenario, we're actually going to remove this output file. Sometimes it'll show up, sometimes it won't, but just delete it. Now, the next step is to get this connected to a database. This is where we're actually going to be storing our users and stuff like that. For me, I've been using Neon database, but you can use whichever database works for you. But for this project, if you want to follow along, you could just use Neon. So it's pretty simple to set up. So after you've created an account, you're able to create a new project. You can just click here, new project, and we'll just call it Auth app and create. Then just go into here and click connect, go into the .env file and just copy this into your .env folder. We'll remove this and copy this. The next thing we'll need to get installed is Iron Session. So let's go ahead and do that. npm i iron-session. Now, one last thing we'll need to do after this is to implement a singleton pattern for Prisma. So go into your src folder and create a lib folder. And in there, we'll create a db.ts file. And I'm just going to go and copy some code over real quick, and I'll go ahead and break it down for you. So the reason we need to implement this code is because Next.js uses hot reloading, which reloads affected files without restarting the server. And every time this happens, Prisma client is created again, and that can lead to the app crashing or the database crashing. So what we've done with this code is essentially implement global caching. to ensure that only one database is connected at a time. So basically, if Prisma client is already active, we'll just use that active client instead of creating a new client. This is really only done in development since we don't hot reload in production. So with this setup, let's go into actually designing the database. So to do that, we're going to need to head into our schema.prisma file. And essentially what Prisma is an ORM, or object relational mapper, which means that instead of having to write raw SQL, we can define our models in a single schema.prisma file, and Prisma will just handle the database tables for us, which is super convenient. And to get started, we're going to go and create a user model. To do that, just do model user and define its properties. So the first thing we're going to define is our primary key, which is our ID. And we'll define it. It's going to be a string. And the ID, or the @ID here, basically just says that this is going to be a unique identifier, and default is just going to tell Prisma to automatically generate a UUID when a user is created. Now, some of the other properties of a user is typically either an email or a username. In this case, we're going to have an email for this user, and it's also going to be a string. And we do want this email to be unique so that two different users can't have the same email. Furthermore, there's going to be a password. So this will be a hash password because we don't want any of this sensitive information getting out there in case the database is hacked or something. And since we're using scrypt for our encrypting, we do also want to store the salt in here as well. And that is also going to be a string. Furthermore, each user is going to have a role, and we'll go ahead and define that role in an enum up here. Basically, the role determines what kind of access a user has in our app, and we can add more to this if you want, but for now, we'll just keep it to user and admin. And something we also want to do is to default the user to, or default the new account to be a user unless otherwise stated. We'll also have this created at field to store when the user is created. We'll also have an updated at field for when the user is updated. And this is really just good for just tracking activity. Cool, now that we've created our user model, we'll need to generate and migrate this over so that we can actually apply the changes that we've made. To do that, you're going to type npx prisma generate, and then also do npx prisma migrate dev to actually get that over to our database. And before I do that, just to show you what I'm talking about here, if you go into your tables in Neon, it's going to be empty. There's not going to be anything here. And then after we run this, and after we run npx prisma migrate dev, we're going to see these tables get generated inside Neon database. Awesome. Now that it's going to ask for a name, you can just name it something like create user. Cool. After refreshing, it should show us, yeah, you'll see that this user model or table has been created. Cool. With that out of the way, we can actually get into creating the sign-up flow for the user. And for those of you unfamiliar, we are using the app router in Next.js, which essentially organizes our app based off of the folder structure. So in this app, if we go into the app directory and we create a sign-up folder, that's essentially going to be the sign-up route. So if we go to main page / signup, that will take us to this page, and we'll have to create a page.tsx inside of this folder for Next.js to recognize this. Now, the main focus of this project is going to be on the authentication flow and not so much about the form creation and the front end stuff. So I'm just going to copy and paste some code that I've created already. I'll go and briefly explain what's going on here, but this is just really standard React stuff, React forms essentially. So what we're doing is, since this is going to be a client component, we use the use client directive, and basically we'll have a email field, a password field, and then an error state for any sort of errors that might pop up. We'll also have a loading and set loading or a loading state for when the user submits their information and the page needs to load. We'll use useRouter for routing, and basically this is our handle submit logic here, which will send our information and credentials to the backend to our API/auth/signup route, which we'll create in just a second here. There's also going to be very just simple password checking. We're just going to check the length of the password. Obviously, you can implement much more stringent checks in your own app, but just for this application, since we're really just working on the authentication flow, we're not going to be too concerned with the actual strength of the password. And this is basically just what the form is going to look like. Don't worry if you're not able to catch all of this at once. I'll go and link the repository to this so you can use this exact same styling if you want. If not, that's totally fine. Hopefully at this point you'll have enough experience building forms to be able to pretty quickly build something like this on your own. And something I'll do is I'll just go ahead and run this project so that you can see what it looks like. And something else I'll also do is I'll change the main page of this. This is just the Next.js boilerplate code that I'm going to get removed and create my own. So this will just be the home page on the website here. And to do that, we'll go and get into localhost. And we have our signup page set up, so we'll go ahead and click right into that. So nothing else is really hooked up now. If you just type anything in here, nothing's really going to work. So the first thing we're going to do is actually set up that API route that we're sending our credentials into. So remember, it's getting sent to API/auth/signup, and to do that, we'll have to create the API route. And very similar to how we created the signup page, we just go into here and type API. Make sure we spell this correct. And then inside this API folder, we're going to create another folder called auth and signup. And inside of this signup page, instead of creating a page.tsx, we're going to be creating a route.ts file. So essentially, every file called route.ts or route.js becomes an API endpoint. We use TS because we have TypeScript set up, but if you don't, you just use route.js. That becomes an API endpoint, and any file that's page.tsx or page.js becomes a web page. Now let's go ahead and actually build out this API endpoint. So to do that, you write export async function, and this is going to be a post request since we're sending our email and password from the front end to this endpoint. It's going to be a request, and it's going to be a next request. Now, the first thing I'll do is wrap this in a try-catch block to make error handling and logging a little easier to read. So first thing I'll do actually is just create the handle the error. So we'll just console.error, any sort of error that shows up. We'll just put maybe something like signup error, and then actually log the error here. And then we'll return a response to the front end. Usually it's something like internal server error. And we'll return a status 500. So first thing we'll do is destructure the username and password, or email and password, I should say, from our request. And the next thing we're going to do now is to check to see if there is a valid email and password. So if there isn't an email or if there isn't a password, we'll go ahead and return an error. And we'll return it in the form of a JSON. Email or password are required. So we want to send this descriptive message over, and we'll also send a status of 400. Cool. And we'll also do a bit of an email check or the password check in the backend as well. very similar to what we did in the front end. And basically, it's just to double check that the password is indeed at least 6 characters long. Awesome. Now that we've gotten that verified, the next step is to create the sign-up logic. Now, technically, you could write all of this inside of our API route, but to make things a little more reusable and clean, we'll go and create a separate file to handle all of these functions, essentially. So now go back into the lib folder, short for library, and create another file here. We'll call it auth.ts. I'll close out some of this. So the first function we'll be creating is a signup function to handle all of the signup logic. So what we'll do is we'll have to export this, and this is an asynchronous function. And something to note is that this signup function will take a couple of inputs, the username or the email and the password, both of which are strings. And inside here, we're also going to do a try-catch block. And like before, I'm just going to log the error first. Okay, so the first thing we want to do when the user is signing up is to actually check to see if there is a user existing already with the same email. And to do that, we're going to have to query our database. And what we'll do is we'll store this inside of an existing user variable. To do that, we'll have to go ahead and query our database. And remember, we have our db.ts function here, so we just import database like this. And we want to find the user. And for each user, we want to find a unique user, actually, where the email is the same. So now that we have the existing user, we want to check to see if it exists. If it does, so if existing user, we want to return an error statement. So now that we've confirmed that there isn't an existing user, we'll need to salt and hash the password that they've provided. And to do that, we'll create a separate function for this. We could technically do it inside of our signup function, but with the hash password function, we're going to be calling it a few different times in a few other functions. So we'll go ahead and create a separate function. So first thing we'll do is we'll also do an export async function here called hash password. And what that does is it will take in a password, which is a string. And the first thing we'll do inside our hash password function is to generate a salt for the user. And a salt is essentially just a long string of random characters that we add on to the password to increase the security, so that if for some reason 2 users had the exact same password, that the hash password will still be different. Essentially, this just adds an extra layer of security. And we'll use the crypto library and use random bytes. And we'll need to convert it to a string. Cool. Now, after we've created the salt, we need to actually hash the password. And to do that, we'll need to use the scrypt method that's provided by crypto. And what I'll do is I'll actually define a new variable for that. So basically what's going on here is that crypto.scrypt is a callback based function. So we have to use promisify to convert it into a function that returns a promise. Basically just give it, make it a promise version essentially. And we'll have to call it inside of here. And this crypto.scrypt method returns a derived key, which is going to be stored as a binary. So we'll go and do const derived key to get our key, our hash password, I should say. And since it's a promise as we've defined up here, we need to use await. And this method takes a few different inputs. So the first being the password, which we'll pass in, and then the salt, and also a key length, which we're going to define up here as well. Uh, 64 is a pretty standard or a pretty common length. And what we'll need to do is write as buffer, because as I said before, this is a binary object. So we need to specify that by adding as buffer in the end here. Now, ultimately with this function, what we want to do is we want to return the salt that we've created. So we'll do that, salt, and then the hash password, in this case, the hash, and that's going to be the derived key. And what we want to do is convert it to a string, since remember, it is stored as a binary object, and we have to specify that it is in hexadecimal format. Forgot to put this there. There we go. Okay, awesome. So now that we've created the hash password function, we're able to get the salt and the hash for the user. So let's go back into our sign up function up here. So up here, what we'll do is we'll pull out the hash and the salt equals hash password. What we need to do is also await it. Now, one optional step you could implement, and this is just a way to kind of bootstrap the app a little bit so that the first user that is created is going to be an admin, is to do this. User count equals. So basically what's happening here is we're just getting the total user count of all the users in our database. And what we want to do actually is, if this is the first user, so if user count is 0, then we'll make this first user an admin. And to do that, we'll just define the role and use a ternary. And if user count is equal to 0, that means this is going to be the first user, in which case the role will be admin. Otherwise, if it's a second, third, fourth, or fifth user, they'll just be a standard user. Now, with all that information, we can go ahead and actually create our user. And to do that, we'll do const user equals await, and we'll do db.user, and this time we'll do .create. And for this user, we're going to be creating data, and for that, it'll use the email as its email. The password will be the hash password, which is hash. And we'll also save the salt and the role for the user. So now that the user's created, we'll have to return some sort of success message. In this case, all we're going to do is success is true, and also provide the user information. And this should actually be a bracket, or curly brace, I should say. And that should take care of the sign up functionality. And we'll have to go back into our route.ts and actually call this function. So we'll do that by storing it in a result variable. So const result equals await sign up, which we will have to import. And of course, it takes the, remember, the email and the password as as arguments. So at this point, the user has been successfully created, but we haven't created a session for the user yet, meaning even after the sign-up process, they'll have to log in again. So I think in order to improve the user experience, we're going to actually just create the session for the user after they've signed up. That way they don't have to sign in after they've signed up. So go ahead and we'll go back into our auth.ts folder, and in here, we're going to create a function to get and create their session. So first thing we'll do is we'll create a type called session data, so we know what the shape of this object is. And inside of this session object, we want to have the user ID. That'll be optional. We'll have the email. We'll have the role. And we'll also indicate whether or not the user is logged in. And something else we'll also need to do is define session options. And to do that, we'll just create another constant, session options. And that's something we'll plug into our getIronSession function in just a bit here. And for the session options, we'll need to provide a password, which I'll create in just a second here. We'll need a cookie name. We'll call it just auth session. And we'll also need to pass in cookie options. So just to break down our session options, we have the password, which is essentially a secret key used to encrypt and sign the cookie. It needs to be at least 32 characters long for security. So we'll need to generate a key and store it into our .env file. So let's go ahead and do that first. So to do so, we're going to define this env variable, which is session password. Now, there's a number of ways you could generate this security code, but an easy way to do it is just to use this following command here, which is node-e console.log require crypto.randombytes32 to string hex. And what this does is it'll just create a random string of 32 characters. And if you hit run, it'll generate a string here. You can just copy and paste that and insert it into your .env folder. Cool. And the cookie name right here basically just defined the name of the cookie and is how the browser is able to identify which cookie belongs to this app session. And then for the cookie options here, we want to make sure that And in regards to these cookie options here, we set it to secure so that cookies are only sent over HTTPS in production. And we set HTTP only to true to prevent JavaScript on the client from reading the cookie. This is to prevent against XSS attacks or cross-site scripting attacks. We set same site to lax to restrict cookie sending and to set the max age of the cookie to 7 so that after 7 days the user would have to log in again. You can adjust this to however long or short you want, but I think 7 is pretty standard. So now that we've gotten our session options set up, we can actually go and define our get session function. And to do that, we just do export async function get session. And so what we need to do inside of this get session function is to actually just get the cookies from the headers. So to do that, we'll have all of our cookies stored here. Cookie store equals just cookies. And then now we'll need to define our session. And to do that, we'll have to use the getIronSession method, which is what we're using iron sessions for essentially. And the first parameter we want to pass in is the cookies. So that's our cookie store. And we also want to provide our session options that we defined earlier. And something I also want to do here is, since we're returning this session data object, we'll go ahead and define that in TypeScript. So it looks like we're running into a little bit of an error here, and it looks like it might be because password is might potentially be undefined. And to do that, we'll just assert that it's going to be there. We want to make sure that we actually do have this session password here in our .env file. So it is there. We're going to assert that it is non-null. So that went ahead and fixed the error. Now, the next thing we want to do is to check to see if is logged in is true. So what we need to do is this. Basically, all we're doing is checking to see if is logged in exists. If not, then we just set it to false in case that is logged in might be undefined, in which case we could end up with an error. So this is just basically a little safety check here. And with that out of the way, we can actually just return the session. So basically, this is going to return a session object, which will provide our user ID, email, role, and whether or not the user is logged in. So now that we've created our get session function, we can go back into our route and actually create the session for the user after sign up. So to do that, we'll just have to do const session equals await. We want to get session, get that imported. Then what we need to do is actually add the user info to this session. So to do that, we'll just do session.user ID equals result.user. So what happened here was it looks like it automatically did optional chaining for us, which I guess what's happening is that user might potentially be undefined, and that's because we didn't do any sort of check here. Obviously, the sign-up process could lead to an error, so what we want to do is actually make sure that the sign-up process actually went smoothly. So what we want to do is if result.success or not, so basically if it's unsuccessful or if somehow we didn't get the user back, we'll go and throw an error and send that back to the front end. And of course, our result object should have an error, and we'll return a status 400. Cool. That way we don't need to have this optional chaining there. And back to our session, we'll go ahead and define the email inside of the session. So once we've set that, we just need to save the session. Cool. Now that we've created the user, we've created the session, we need to return a response to the front end, letting them know that the whole process ended up happening. So we just want to send a success message. Awesome. So it looks like we've got it all taken care of now. The sign-up flow is pretty much done here. So with this, the user was able to get signed up, and we've created a session for them so that they're signed in right after sign up. So in this next part, we're going to have to create the sign-in flow, essentially. But before we go and actually do that, let's test out our sign-up logic to see if it's actually working. And right now, I'm going to double check. It looks like the client is still running. So we're going to go into the Neon console, and it shouldn't have anything up here just yet. I'm going to refresh it. I don't think we have any users in here created yet. That's right. So we'll go and test it out in our app by creating a test email, test@gmail.com, and we'll just do a very simple test. So this should send us to the dashboard after creating. It says dashboard. This page cannot be found. And that's because we haven't created the dashboard yet. But the user account should be created if we check in our console and we go into application and we look at our cookies. It should say auth session. So it does look like we do have the cookies created. And if we go into our database and refresh it, it will have a user created. So it does look like our sign-in logic works. The only thing is we haven't created our dashboard just yet. But before we build the dashboard and anything like that, we'll finish up the user sign-in and logout flow. It's not going to take too much more time since the sign-in logic is going to be pretty similar to our sign-up logic. And now that we've got a lot of this set up, we're going to end up reusing a lot of the old logic as well. So let's go ahead and create our sign-up page first, or sign-in page, I should say. So inside our app folder, similar to how we created our sign up page, we'll create our sign in page. And similarly, we'll create a page.tsx. Now, like before, I'm not going to spend that much time on this. This is really just meant to be a authentication tutorial, so we're not going to spend too much time on the front end. So I'll just copy and paste this sign in form that I had created and just go over the code with you really quickly. So with the sign in page, what we have is a email input, a password input, and error and loading states. We'll also use router to redirect the user or to route the user. We have a handle submit function. We'll We also have a handle submit function. And inside of that function, obviously, we're just going to prevent default, and we'll send all of our form information to the API/auth/sign-in page. It'll be a post request, and we're going to get some data in response. It'll have a success message. It'll also have some of the user information. And if it's successful, we'll push them to the dashboard. And if there's any errors, we'll go ahead and set those errors in the error state. And we'll go ahead and save it, and we'll go and head to the sign-in page. And this is what it's going to look like. All right, cool. So with the front end built, we need to actually build the API endpoint. So like before, we'll go into the API/auth/signup folder, and this time we'll create the sign in folder, and we'll create a route.ts. So with the sign-in logic, it's actually very, very similar to our sign-up logic. Basically, we're going to have a post route. And since it's very similar, we can actually go and just copy and paste some of the initial logic, which is to, first I'll create the try-catch block like before. Try-catch, and then I'll put the same and the error message is largely going to be the same, so we'll go ahead and put that in there. In this case, it'll be sign in error, not sign up error. And we'll also be getting the email and password from the front end. So this is the same. The only difference now is instead of calling the sign up function, we're going to have to create a different function, which is the sign in function. So to do that, we'll head back into our auth.ts folder, and we'll create the sign in logic. Let's do it up here actually. So same thing, we'll do export async function sign in. And this function will also take an email and password. We'll wrap it in a try catch block like before. And we'll just log the error in the console. And we'll just copy and paste the same message from before, but we'll just put failed to sign in. Now, up here, we actually want to find the user. So to do that, we'll need to query our database like before. So const user equals await database dot find or dot user dot find unique. And we'll want to find the user based off of their email address. Now, if the user doesn't exist or we're not able to find the user, then we need to send an error message. Now, previously in the signup function, we had a hash password function that we used, but when we're looking to sign in, what we actually need to do is compare the hash password with the hash password that is saved in the database. So to do that, we'll have to create a separate function. So let's go ahead and do that. And this function we'll just call the verify password function, and we'll do export async function verify password. And for this function, we're going to be taking in a few different inputs, the password, the hash, and the salt. And those are all going to be strings. And we're actually going to put it over here. So similar to the hash password method, we're going to need to get the hash password from what the user has input. So it's going to be the exact same thing as what we have down here, actually. So essentially, we've gone through the same process of hashing the password, and this is the password that the user has provided with their salt that was saved in the database from before. And we'll need to compare the two, so we'll hit return crypto. So basically what's happening in this return statement is that we're using the crypto's timing safe equal method to compare the password that we have saved in the database with the hash password that was just created when the user signed in. And remember, in the database, it's stored as hexadecimal, So we need to convert that back into binary. And once that's done, it compares both of these values. And if it's the same, it'll return a true value. If it's false, or if it's not the same, then it will return false. And the reason we're using the timing safe equal method here is that basically this method makes it so that it will always take the same amount of time to compare the values, no matter how similar the values are. What this does is it just prevents attackers from being able to measure the response time and be able to guess the password bit by bit using that method. So it's just a safer method to go about it. And what this will do is it will return either a true or a false. So going back into this sign-in function, we're going to define a is valid constant. And what we'll do is we'll go ahead and call this verify password method by passing in our password, our user dot password, and our user dot, and the salt. And if it's invalid, so if not user is valid, we'll return a error message. Otherwise, we'll just return a success message with the user information. Cool. So now that we have our sign-in function set up, we can go back into our sign-in route and import that. So what we'll do is we'll create a result variable, which calls our sign-in method. Oh, we need to make sure to import it. And now, like our sign up API route, we'll also just go and use the exact same logic here to create a session. So we're going to check to see if the result was success or not. If not, then we'll return an error, and then we'll go and create the session for the user. So it'll do the exact same thing here. We want to make sure to import get session. And actually, we'll also send the same response. Awesome. So it looks like our sign-in logic is all set up now. All that's left to do is implement the sign-out logic. Okay, so creating the sign-out logic is going to be very similar to our sign-in and sign-up logic. So we'll head back into our API/auth folder, and we'll create the sign-out route. And in there, we'll also create a route.ts file. And in here, we'll also define a post function. And similar to these, we'll use a very similar error message. To sign out, we'll need to create the sign out logic inside of our auth.ts folder. So this is actually super simple, and we'll define it at the bottom here. So with the sign out function, all we need to do is define it async. So all we need to do is get our session. And what we need to do is just call session.destroy. And that will pretty much log us out. That will essentially destroy the cookie. So we just go back into our sign out API route, and then we just go and call our sign out function. And we'll return a response. And that'll do it for the sign out function. All we need to do now is go to the front end and implement the sign out logic. So since logging out requires user interaction, essentially clicking a button, our logout button should be a client component. So I'm going to go and build a component, a reusable sign out button right now. So we'll go back into our app folder and we'll create a components folder, which will store our components. And in here, I will create a sign out button. So I've actually already created this sign out button and it's pretty straightforward. So I'll just go and copy and paste it over and explain the code to you guys real quick. Essentially, since this is a client component, we need to use the use client directive. And inside of this button, we're using the use router to handle navigation. We have a sign out function, which calls or fetches our API /auth/ sign out route, which we just created here. And if it's successful, it'll redirect us to the sign in page, I should say. And if there's an error, it'll go ahead and log it. And it's just a very simple log out button or sign out button that's just red. And we'll go and import this in our pages later when we need to use it. So now that we've created that, we need to actually just build out some of our dashboard and admin pages and actually see this in action. All right, so now that we've completed the user's sign up, sign in, and log out flow and all of that logic, we need to actually build out these pages so that only authorized users can visit particular pages. So in this section, we're going to be going over role-based access control. Essentially what that is a way of controlling what actions different users are allowed to do inside of our application based on their role. So for example, in the example provided earlier, the dashboard will only be accessible for a user if they're logged in. Currently, we don't have that created yet, so let's go ahead and do that. We'll head into our app directory and we'll create the dashboard folder and we'll create the page.tsx in there. And using this ES7 snippets plugin, we'll go and do RAFCE. And if we go to the and we'll just go ahead and name this dashboard. So right now, nothing's protected. If we just go into our app and we go into dashboard, it'll just say dashboard. It won't redirect us if we're logged out or anything. So let's go ahead and actually build that out. So right now our dashboard actually runs on the server, so we're actually able to call our get session function. And what we could do actually is just to define our session here and do await get session. And what we'll need to do is, since this is asynchronous, we'll need to say async here. And let's just console log our session real quick. And let's check our console. Yeah, so you'll see here we have our session object. It'll show that we are logged in. It shows the user ID, email, and role, which we had defined earlier. And remember, since this was the first account that we created, the role technically is an admin. Now, what we'll do now is we'll check to see if the session exists, if the session does not exist, or if the user is not logged in. Then we'll go and redirect them. And we'll redirect them to our unauthorized page. You can also redirect them to our sign-in page, whichever works. In this case, we can just do sign-in. We can redirect them to a separate page if you want, but this is essentially the logic for it. Now, the next thing we'll do is if they're logged in and we have their user ID, which is going to be in the session, we'll look them up based off of that user ID. So what we'll do is we'll query the user in our database. So we'll do const user equals await, and then we'll have to import our database again, .user.find unique. Oop. If for some reason the user doesn't exist, we'll just redirect them to the sign-in as well. So if now, instead of having you guys watch me code out the dashboard, I'm just going to copy and paste this dashboard that I've created beforehand. And what I've also done in here is I've imported the sign out button. So this is what the dashboard will effectively look like. It'll just display the user ID, the email, and the role. Of course, when you're building a a full-scale app, there's going to be a lot more information that you'll be pulling from the database, and you can use that to display more information. So let's go ahead and test out the sign out function since we had just built it a little earlier. Cool. And then if we go to the dashboard, it'll redirect us right back to the sign in page. Yep. Okay, cool. So let's actually test out our sign in logic. Cool. It looks like it's working. So right now, our dashboard only protects a single page. But what if we want to protect an entire group of pages, or we want to make or restrict access to admins only? So let's go ahead and create an admin route that only admins can access. So in here, in the app directory, I'll create a admin file. And in here, I'll create a page.tsx. And using the snippets, I'll just do refce and change this to admin page. Now, the user that I've created so far will have access to this page because it is an admin. So I'll go ahead and create a secondary user called test2@gmail.com. Oh, we need to create a new account. That's right. And as you can see here, this secondary user is going to be with the role of user. So if we go to admin right now, it will let us use it because we haven't defined any sort of permissions for it just yet. So similar to our dashboard, we could just use the same logic. For example, we could just do const session. And similarly, we could check to see if they're logged in, or to check to see if they're an admin by doing this. So basically, if they're not an admin, they get redirected to the sign-in page. So that totally works. But what if you had a lot of different admin pages that you wanted to wrap? You could import this same logic onto every single page, or you could actually wrap it in a layout.tsx. So similar to how this layout is wrapping our whole app, we can wrap this admin route in a layout.tsx. So to do that, you can just go into the admin folder and create a layout.tsx. The syntax is going to be very similar to our layout.tsx, so we'll just go ahead and copy that over. Now, instead of the root layout, it's going to be the admin layout. And we're not going to be defining a body or HTML here, actually. And we'll just use a div to render our children. And what we'll do is I'll just copy this over onto the layout. We'll import. And this will effectively have accomplished the same thing. So if we go to the admin page, it'll redirect us. However, if we sign in with, say, our old email, it should work, or our original admin account. And we want to go to the admin page. There you go. Obviously, you could build this out to be a little prettier, and you could also create the unauthorized routes as well. But there you have it. This is how you implement authentication and authorization in Next.js using Iron Session. Hope you guys found this helpful. Thanks for watching, and I'll catch you guys next time.